Last episode, we left the Dabba database in good shape, split into shards, indexed, humming along, surviving, growing, staying fast. But I left you on a promise. The fastest query is the one you never send at all. And it's been sitting right there in the corner of the frame this whole time. Look at that little layer in front. Every arrow it catches is a question the database never even hears. Today we walk into it. Because it turns out the fastest work isn't fast work. It's work you skipped. Now hold on. Back in episode 8, Vaj already made reads faster. We added followers, copies of the database, and spread every read across them. So why do we need anything else? Here's the catch, and it's a good one. A follower is still a database. When a read lands on it, it still has to go and find the row, walk the index, reach down to disk, pull the bytes back up. You made the queue shorter. You didn't make the work smaller. Memory doesn't do any of that. Memory already has it. Reading from memory instead of a disk-backed database is routinely 10 to 100 times faster, not 10%, 10 times at the floor. Same answer both times. One of them worked for it. The other one just remembered. Picture the restaurant again. The one from episode 2. The dining room, the kitchen, the waiter running between them. Now the menu. Back in episode 7, we put Dabba's menus in the database, right alongside the catalog and the reviews. So the menu is data. It lives in the kitchen. So here's the absurd version. A table asks what's in the biryani. The waiter walks to the kitchen, reads the menu, walks back, tells them. Next table, same question. Off he goes again. Same walk, same menu, same answer. 200 times an evening. No restaurant on earth does that. They print the menu once and put a copy on every table. That's the whole idea, and it's smaller than people make it sound. The menu is the data. The cache is the fact that you don't ask twice. 2 words and you half know both already. When the answer's already there, that's a hit. When it isn't, that's a miss. And a miss means you do the whole walk anyway. Plus, you stop to write the answer down on the way back. So a miss is slower than having no cache at all. Which means this entire idea lives or dies on one number. What fraction of the asks are hits? The hit ratio. And when that number gets high, the maths get silly. Uber runs a cache in front of their database that serves over 40 million reads a second. On one path, 99% of those never touch the database at all. Serving that straight from the storage engine would have needed around 60,000 CPU cores. With the cache in front, 3,000. Same answers. 5% of the machines. So who does the remembering? Somebody has to check the cache and somebody has to fill it. And the most common answer by a mile is that your own code does. It's called cache aside and it's 3 steps. Ask the cache. If it's there, done, send it back. If it isn't, go ask the database and on your way back, drop a copy in the cache so the next person doesn't have to. That's it. That's the pattern behind most of the caching you have ever used, Uber's included. It's also the one an interviewer expects you to reach for first. So if you only keep one, keep this one. And notice where it sits. Beside the path, not in it. Nothing breaks if the cache disappears. You just get slow. That's not an accident, that's the point. A cache should never be the thing your system can't live without. Cache aside puts all that logic in your app, which means every service that reads has to remember the 3 steps. So push the logic into the cache instead and you get 2 patterns, and they are the trade-off of this episode. Read through handles the reads. Your app just asks the cache always. If the cache doesn't have it, the cache goes and gets it. Your app never even learns there was a miss. Write through handles the writes. You write to the cache and the cache writes straight through to the database before it tells you it's done. The cache is never wrong. But every write now pays for 2 hops instead of 1. Picture BookMyShow. The show times for a film change maybe once a day. Read that hard, cache it hard, nobody gets hurt. But the seat map, which seats are gone, that changes every few seconds. And if your cache says D14 is free when it isn't, you just sold the same seat twice. So, read through says make the read simple and fast and accept that things drift a little. Write through says never let the cache lie and accept that writes cost more. And real systems run both. Read through for the reads. Write through for the handful of things that must never be wrong. Two more worth knowing by name. Write behind, write to the cache, tell the user it's done, flush to the database later. Fastest writes you'll ever ship. And if the cache dies before that flush, the data is gone. And refresh ahead. Quietly reload a hotkey just before it expires. So nobody ever eats the miss. You don't pick one of these and marry it. You pick per piece of data. And that honestly is the whole skill. Right. I owe you something. 5 episodes ago, when we met the waiter, the load balancer, I flagged a problem with sticky sessions and said we'd fix it in the catching episode. This is the catching episode. Here was the bug. Your login, your cart, that lived in the memory of one server. Server 2 dies and you are logged out with an empty cart because your stuff was trapped on a machine that doesn't exist anymore. So take it off the server. Put it somewhere every server can reach. Redis or the key value store from episode 7, the one I said is so fast, people just use it as a cache. Today we actually do that. Session token as the key, the session itself as the value, and a TTL so it cleans up after itself. And now any kitchen can serve any diner. Kill any server you like. Nobody loses their cart. That is what stateless actually means. Every cache is a copy of something that might have already changed, which sounds alarming until you ask the only question that actually matters. How bad is it to be wrong and for how long? A view count says 4000, it's really 4006. Who cares? Be wrong for a minute. Nobody will ever know. Dabba's menu price. The restaurant bumped the biryani by 20 rupees at 4 o'clock and you're still showing the old one. Now, it matters a bit. A few minutes late is survivable. That seat map. Wrong for 5 seconds and you've double sold a seat. A UPI payment? Never. Not for a millisecond. Money doesn't get read from a copy that might be stale. You go to the source every single time. There's no formula for where that line sits. You just decide per piece of data. And you already know the dial that controls it. TTL from the phone book back in episode 2. Long and you make fewer trips but you're slow to notice change. Short and you're always fresh but you do more work. Same dial, whole new job. So you set a TTL and you move on. Except sometimes you can't wait for it to expire. The price changed now and you need the cash to know now. That's invalidation. And it has a reputation. Everyone quotes that line. Almost nobody says why. So here's why. You cached one line on the Dabba screen. Biryani 240 rupees, in stock, 4.2 stars. One line, one key. Now look at where it came from. The restaurant changes the price. The kitchen runs out of biryani. Somebody leaves a review. 3 different systems, 3 different teams. And any one of them, on its own, quietly turns that cached line into a lie. And not one of them knows your cache exists. That's the hard part. Deleting the old thing is easy. The trouble is that the thing you cached was never one thing. It's the answer to a question that a dozen systems can change without ever meaning to. And there's no rule that tells you which ones to wire up. Somebody just has to know. One cousin worth the name. When a really popular key expires, every request that wanted it misses in the same instant. And they all stampede the database together. That's a cached stampede. And the classic fix is beautifully petty. You scatter the expiry times a little so they don't all die at once. Last episode, I told you every index you add is a promise you have to keep. Same deal here. Every cache you add is a promise that somebody, somewhere, remembers to tell it the truth. Now, everything we just built lives in your data center, which is wonderful, right up until the person asking is nowhere near it. Back in episode 3, I told you that bandwidth is why the CDN exists. That was true. It was also about half of it. Because here's the thing, no cache in Mumbai can fix. Light in fiber moves about 200,000 kilometers a second. Mumbai to a server in Virginia is roughly 13,000 kilometers. There and back, 26,000 kilometers of glass. Even at that speed, that's 130 milliseconds minimum. In the real world, it measures nearer 190. And not one of those milliseconds is your server being slow. Your cache made the work zero. The distance didn't care, so you can't make it faster. You can only make it shorter. So you stop moving the user to the data. You move the data to the user. Copies of it, sitting in cities all over the world. Those are edge locations, and the edge just means the point closest to the customer instead of the center. And this isn't abstract. CloudFront alone runs 13 edge locations in Mumbai, 13 more in Delhi, 4 in Bengaluru. Not somewhere in the cloud, a few kilometers from your phone. Franchise the restaurant. Same menu, a kitchen in every neighborhood. Your phone asks the nearest one. If it's got the thing, done. 5 milliseconds, it never left your city. If it hasn't, the edge asks upstream through a layer called an origin shield, which exists for exactly one reason. When a million edges all miss the same thing in the same second, the origin gets asked once, not a million times. Then the answer comes back down, and every layer keeps a copy on the way. And that's the bit people get wrong. A CDN doesn't mean your server never gets called. It means it gets called rarely. It's a cache. Hits, misses, TTLs, invalidation, every single thing from the first half of this episode just spread across a planet. CDNs cache. But not everything that caches is a CDN. Which brings us to the thing that shouldn't work at all. 9th of March 2025. Champions Trophy Final, India, New Zealand. 61 million people watching at the same moment on JioHotstar. Live. And your first instinct should be, hang on, live means it's happening now. You can't cache now. Everybody's stream is their own. Except they aren't. Live video doesn't travel as a river. It gets chopped into segments. Little files, 2 to 10 seconds each. And the instant a segment is finished, it's finished. Frozen. A file like any other file. So 61 million people aren't asking 61 million different questions. They're all asking for segment 4532. The identical already finished file. 61 million people wanting one frozen thing. There is nothing on the internet more cacheable than that. Remember the 128 terabits from episode 3? This is how. Not one building in Mumbai is serving it. A copy of segment 4532 already sitting in every city before anybody asked for it. The only piece that can't be cached is the little file that says which segment is current, and that one's a few seconds old anyway. That's the whole trick. So put it together, a cache is one decision made over and over. Don't ask twice. Put that decision next to your database and you skip the work. Put it next to the user and you skip the distance. Same idea, 2 scales, and all of it costs you the same thing. A copy that might be a little bit wrong and somebody deciding how wrong is fine. But look at what we never touched. Every one of those arrows was a read. Somebody asking, and the whole trick was skipping the work. Writes don't get skipped. When you place an order, that order has to actually happen. The payment, the restaurant, the confirmation, the notification. And right now you're standing there watching a spinner while every one of them finishes one after another. So, what do you do with work that genuinely has to happen? Just not right now, and definitely not while somebody's watching. That's not a problem you can skip your way out of. And it's where we go next.